Have you ever just stopped and realized how much of our world is, well, all mixed up? I mean, seriously, from the air we breathe to the food we eat, almost everything is a blend of different things. But here's the really cool part. There's this hidden science that we use every single day to take all those mixtures apart.
Okay, let's just dive right in with a perfect example. On the one hand, you've got a field of tall green sugarcane. On the other, these pure white sugar crystals in a lab. Now, they're basically two sides of the same coin. But how in the world do you get from that plant to this crystal?
That's the big puzzle we're going to solve together today. And believe it or not, this one question opens up an entire field of science that is absolutely essential to our modern lives, even though most of us never even see it in action.
So, to solve our sugar mystery, we first have to learn how to spot the difference. We need to understand how things are mixed in the first place, because, as it turns out, not all mixtures are created equal.
No, really, just think about it for a second. The salt water in the ocean, the vinegar in your kitchen, maybe even the cup of tea you're drinking right now. They're all mixtures, but they don't all act the same way. Not at all.
So, let's do a little experiment. Here, we've got a laser beam passing through salt that's been dissolved in water. Now notice something. The path of that laser is practically invisible inside the beaker. The light just zips right on through.
But now, look what happens when we do the exact same thing with a mixture of milk and water. Whoa! Suddenly you can see the beam's path glowing bright and clear right through the liquid. Something in the milk is scattering that light, totally revealing its journey.
And the effect gets even more dramatic with chalk powder mixed in water. Here, the light scatters so much that it creates this kind of cloudy, diffuse glow. It's the same laser, it's the same water, but the type of mixture completely changes the result. So, that little laser experiment just showed us the two fundamental personalities of mixtures. You've got your homogeneous mixtures, like the salt water, where everything is so perfectly blended that you can't see the individual parts. And then you have heterogeneous mixtures, like the chalk and water, where the components are all lumpy and uneven and big enough to see.
You know, that perfectly blended, uniform mixture? It has a special name. It's called a solution. That's when one thing, the solute, dissolves completely into another, the solvent. It creates this super stable, even mix. It's like the ultimate smooth blend.
But, okay, just knowing something is a solution isn't the whole story. We also have to ask, why does concentration matter so much? Because knowing how much of something is in a mixture, well, that can be a real balancing act between being helpful and being harmful.
I mean, just take the work of Indian pediatrician Dilit Mahalanobis. He came up with the oral rehydration solution, or ORS. It sounds simple. It's just a solution of salt and sugar and water, but its incredible power is in its precise concentration. That simple, well-measured mix has saved millions and millions of lives from dehydration.
And once you start looking for it, you see this principle literally everywhere. The glucose in a hospital IV drip has to be at a very specific concentration to be safe for our bodies. And that vinegar you put on your salad, that's just a 5% solution of acetic acid in water. The numbers really matter. Take a look at this number, 0.9%. That's the exact concentration for a standard saline drip. Why? Because it's perfectly balanced with the fluids in our own bodies. Any more or any less, and it could cause serious harm.
And honestly, that's true across the board. For farmers using pesticides, for doctors giving out medicine, for companies making the food we eat, getting the concentration just right is absolutely everything.
Okay, so we get it. There are different types of mixtures and concentration is key. So now, let's get to the fun part, the art of unmixing. How do we actually take these things apart and finally solve our sugar puzzle? Let's crack this case. All right, so to get from that green plant to those little white crystals, scientists have to separate the sugar from everything else in the sugarcane juice. And to do that, they use a technique that is surprisingly elegant. The answer is crystallization. Here's how it works. You start with a hot solution that's totally saturated with sugar. Then, as you let it cool down, nice and slow, the water just can't hold on to all that sugar anymore. So the pure sugar molecules start to find each other, they line up in these perfect solid crystals, and they leave all the impurities behind in the liquid. And just like that, you've got pure sugar. But wait, crystallization is great for separating a solid from a liquid. What if you, say, accidentally mix two liquids that dissolve in each other, like acetone and water? You can't just cool that down and hope crystals form. You need a completely different tool for that job. And that tool is called distillation. This whole setup is so clever because it uses a simple fact. Different liquids have different boiling points.
So you heat the mixture, and the liquid with the lower boiling point turns into vapor first. Then you guide that vapor through a cool tube, that's the condenser. It turns back into a pure liquid, and you just collect it in another flask. Simple as that.
You know, this technique isn't new. It's been used for centuries. In Kannauj, India, there are performers who use a traditional form of distillation to capture the beautiful earthy smell that comes right after the first rain. They literally distill the essence of the earth into a perfume they call mitti ka itar. I mean, how incredible is that?
So let's just zoom out for a second. This science of mixing, concentrating, and, of course, unmixing isn't just for fancy labs and ancient perfumers. It is actively and constantly shaping the world you live in, right now, every single day.
Think about this. The next time you pick up a package of food and you read that nutritional label, you are looking directly at the results of this science. That label is telling you the concentration of fats, sugars, and proteins, all figured out by separating and measuring the components of the food.
When you get right down to it, these separation techniques are the invisible engines of our entire world. They're what turn crude oil into fuel, what pulls salt from the sea, what purify the active ingredients in our medicines, and what makes sure our food is safe to eat.
It really makes you wonder, doesn't it? From the gasoline in your car to the clean water coming out of your tap, just think about all the hidden mixtures around you that had to be carefully unmixed by science just to make your day possible. What else is out there?